morning, everyone. I see more people are tuning in. Thank you so much for being here today. Hi, everyone. Hello, good morning. All right, I'm admitting more people as they come. Thank you so much for being here nice and early. Welcome to the first day of the Small Farm Conference. This is our 35th year. This is our 35th annual anniversary. My name is Beatriz, and I am with the Community Alliance with Family Farmers. I am the Membership and Communications Coordinator, and I will not be your host today, but I have the panelists here, which I want to thank so much for being here so early. I also want to thank our sponsors for making this conference happy and happen. Happy and happen. I'm so glad to see all of you here. I see more of you are tuning in. And this is the SAP analysis pre-recorded video workshop. I do want to let all of our participants know that we have a Q&A function. If you please want to use it, it does make it easier for our panelists to find your questions. So if you want to use that Q&A function to ask questions, that would be great. Also, this workshop is being recorded. So if you don't want to have your camera on in case you don't want to be recorded, that is totally fine as well. Please be mindful that while we play the video, we would love for all of you to stay muted as we enjoy the video. And any questions could either go in the Q&A, but if you prefer chat, that is also okay. All right, and without further ado, I'll let the panelists take it away.
Hey everyone, my name is Nolan and I help prepare the video for today. I'm going to pull the video up and play it. And like Bea said, feel free to leave questions in the chat or in the Q&A spot.
Hello, my name is Hannah Call, and I am the Ecological Pest Management Specialist at Community Alliance for Family Farmers, or CAF. I'm on the ecological farming team, and more broadly, the ecological farming team provides resources for climate-smart farming and building soil health, as well as ecological pest management practices. Today, we're going to talk about a major problem. Over-fertilization can lead to wasted costs for farmers, crop problems, and losses with increased pests, diseases, and extreme soil salinity and environmental issues, such as nutrient runoff and leaching, damaging surface and groundwater, and increased greenhouse gas emissions. However, growers have few available tools to make informed real-time decisions about fertilizing. This can be especially challenging for regenerative farms that typically use more complex nutrient inputs, such as manure, cover crops, and compost, focusing on building soil health rather than the use of synthetic fertilizers. SAP analysis is a relatively novel technology that can allow growers to assess nutrient needs of crop plants. In this video, Clayton Handy of Handy Farms will delve into details of what SAP analysis is, how to take SAP samples, and how to do SAP analyses of these samples. SAP analyses looks at what nutrients are moving through the leaves over time, allowing growers and technical assistance providers to have real-time data about plant nutrient levels for several diverse cropping systems. SAP analysis has real potential to help growers hone in on fertilizing, allowing them to avoid over-fertilizing. Part of the motivation for this video is that CAF previously did a field day at Handy Farms, where Clayton talked about using SAP analyses and several other unique regenerative practices. There was a lot of interest from attendees, and many were interested but not able to make the event. Today, we are interviewing Clayton Handy at Handy Farms about SAP sampling and analysis.
Yeah, so my name is Clayton Handy. We are here at Handy Farms. You know, I wanted to do a regenerative farm from the ground up, and that's where I started. I made a lot of mistakes and learned as I went, but yeah, that's where we're at. This is Handy Farms. I'm also a consultant for an agronomy consultant, PCA, and I've worked for corporate farms, mainly permanent planting, and now as a consultant I work with lots of different row crops and permanent plantings up and down the North State. I got to a point in my life where I was like, okay, I can either go the route of orchardry farming, agronomy, or I can go and try to be in the system, right? Try to, work in a corporate farm or a large farm and try to make a difference there, or just be open-minded about different practices and try to angle it that way. Ended up at a large corporate farm. They ran 15,000 acres of prunes, almonds, walnuts, and pecans. And while I was there at a large corporate farm, I tried to, incorporate different regenerative practices. I always called myself like an avid regenerative ag junkie, a closet regenerative ag junkie in a very corporate conventional farm. Nobody knew, but I loved like strategizing, trying to figure out like how can we financially make regenerative ag be appealing, right? How can you make it appealing, and how can you also paint it in the light of saving money and helping the bottom line? And with actually the second thought of being, it's going to be better in the long term. Because we have to understand, like farms, their primary role, their primary goal is to make a living. They have to be profitable. I mean, that's number one. If they're not, how can anybody be sustainable? First, you have to make sure that it can stay afloat, right? Back to my beginning, I started a corporate farm and saw the need for methodologies, testing methodologies to ensure that you could start changing your cultural practices without risk, right? And the only way that I found we could do that is with a thorough, reliable testing methodology, right? And so I've always been interested in looking at new or underutilized testing methodologies, because if they can give us some insight on what's happening and give us a little more peace of mind if we start changing some things up, so that we can then get on that road to really unlocking some potential, not only to save money for the company and make or increase profit margins, right? But also at the same time, we're starting to see a change in soil health, right? And starting to see a change in nutrient density, and starting to turn our soil around so that it's better regenerating, right? Better for future generations, better for even the current generation. If we look at the history of testing, we got pretty excited about soil testing when we did start utilizing that many decades ago, right? It was exciting. And then tissue testing also was an exciting thing, also many decades ago. But more importantly, we have to understand that there are so many components to the plant's ability to take in the nutrients that are in the soil, right? We know formulation has a lot to do with it, availability has a lot to do with it. We know that these soils are, probably my soils alone, we're looking at 15,000 pounds per acre of potassium, just in the first 6 inches. There is plenty of potassium. But when I take a sap test, I'm still low in potassium. Again, availability is everything, formulation is everything. And what helped unlock that was biology, right? So we as farmers need to understand the importance of letting the tree or crop tell us what it is deficient in, right? And the closer we can get to that, the closer we can hone in that nutrient deficiency. And that's why soil is great. Soil testing is great, and I will always do that. But it's just simply like a reference point, right? Okay, we know that there's a lot of potassium. We know that there's actually a lot of calcium, just not in available form. A chemical soil test gives us a little bit of insight into what's available as well. But still, even if it is available, there are so many different dynamics that happen in the soil, antagonism and water and heat and et cetera, right? A lot of variables that affect the uptake of even things that are available. And also, where are those roots? Are they covering every aspect of, some of our permanent plantings are in drip. Those roots don't necessarily, trunk to trunk, utilize all that ground. I mean, they're very concentrated underneath the drip. And so in order to fully understand where our nutrients are we really do need to rely on that tree telling us, or that plant telling us, that annual. And so tissue is very important, but next level is sap analysis, because it just gives you real time. So if you can compile the two, tissue and sap analysis, so you have a rear view mirror, right, what's accumulating over time, but also like what's happening now, then that really should be our emphasis, right? Because of so many variables that go on in the soil and what actually happens down there. We really do need to understand, like I could do everything that I know how to, biologically speaking, and I have, but yet I still come up short on certain nutrients, right? And I know that because of sap analysis and a little bit of tissue, right? And so, yeah, that we can never rely on one, but we utilize all tools that we can in order to get to that maximum uptake of the nutrients that we need. And also, in return, what? Production, right? Yield, reproduction, and growth. Let's look at tissue first, right? Tissue, we take a leaf sample, we send that leaf sample in, and it's dried and ashed, and then we analyze the elements that are in that tissue, right? That is wonderful, because that gives us kind of what we have over time. That's a buildup of what we have in the structure of the plant, right? Cell wall included, right? Because we dry it, we ash it. Sap analysis is actually taking the sap that's in the tree without compromising the integrity of the cell structure, the cell wall. And so through a process, they extract the sap only out of that leaf. It's like instead of a bone sample, we're doing a blood sample. And that gives us not the buildup over time, but that real snapshot in that moment, what's happening. And that can be very helpful when you're trying to manage, or let's say you want to make a change, then you have a snapshot view of what just happened, right? You can, it's a blood sample. It's very real time. Now, if you look at sap analysis, you're taking the blood, and you're taking the old leaf, and you're taking the new leaf, and you're not compromising the integrity of the cell wall. So you really get what's in the soil, what's available at that moment in time. And then you're comparing the two, right? You're comparing the old leaf to the new leaf and every nutrient, right? I've never had a tool like that. I've never had a tool where I could predict and give me real-time data, right? And know exactly where I'm at as far as nutrient management goes. So now I can take any product, let's say I get whatever product, and they say, well, we've got this new formulation of potassium and it seems to work really well. Okay, I'll try it. Here's my standard potassium, here's the new formulation. And I can take a sap analysis test, like let's say 3 days before, and then I'll take another sap analysis test 3 days after. And I can watch between these two formulations what was most effective. I mean, they're very sensitive. Sap analysis is very sensitive, right? And so it's taking it at the same time in the morning. It's taking it, at the same moment in time, either before or after an irrigation, right? So all things are equal, considered equal, because it's such a sensitive test. But the power in that sensitivity then gives the farmer back that control and that ability to sleep at night if he wants to make changes. Let's say he wants to back off on fertilizer this year because he's planting a cover crop. Okay, you can do it. Just test. Let's watch nutrient management and the ratios, most importantly, the ratios between the old and new leaf. Make the changes you want, but now we'll be able to watch those ratios and say, you know what, you're good, you're safe. Those ratios are now down to 5%. Let's use nitrogen still. 5% more in the old leaf than in the new leaf. Okay, now deploy. Before you're tapping into self-sabotage basically and sloughing off that old leaf, because we see it all the time, right? At a certain point in the year in our permanent planting, we'll get that yellow leaf. That's pulling all the nitrogen out of that leaf and sloughing it off because there wasn't enough in the system. Oftentimes, there's plenty in the system, we just can't utilize it, right? Formulation has an effect. We've learned that too. And also biology has an effect too. And overall health and heat, right? There's many components to this, right? But point being, we can finally say, we often, in the corporate farms that I work with, we would often say, okay, we are low, we need something immediate, we did a foliar at a lot less rate, right? Because it goes right on to the leaves. But it's almost addicting as an agronomist. Like, we so badly need information like this if we want to make changes. And I know all of us on the team were like, oh, sap analysis comes in tomorrow. Excellent. We did this and this and this. Let's see if we made a difference, right? And any product, let's say you want to try, go for it. I mean, you become your own testing team, like, because it's really that easy. You just make sure that you test before, make sure you test after, all things being equal, right? And you have the power now to decide, I'm not going to use that, I am going to use that. But again, if a farmer wants to make changes in this day and age, where labor is more expensive, fertilizers are more expensive, and our margins are only decreasing, like, if you want to survive, you probably ought to think about making some changes. Sap analysis is a shoe-in for that, like, because you can actually make changes and sleep at night. You know, sometimes the cost, will say, farmers lie, that's too much money, because it is. I mean, you're looking at almost $100 a sample, and then also $100 of shipping, so $200. I do one every 100 acres or so, depending on the terrain or your soil type, looking at web soil survey. But without fail, there's been more savings than there ever will be in expense on sap analysis. Yeah, sure, you might see that you're a little bit low in other things, but as you work through what you're deficient in and maximize your production and growth, right? There's usually almost always savings when it comes to some of our synthetics, nitrogen, potassium, and phosphorus. And more importantly, the timing of those applications change a little bit, right? And then we become more efficient at utilizing what we do use. But yeah, I mean, it's been pretty consistent. You save money because you're finally able to then test and not guess when you're making a new program, right? And it's perfect for people getting into biology or regenerative ag, because you can make that transition without taking risk. A few technical points to sapping. We do it in the morning when the trees are still in transpiration instead of respiration, right? When they're actively pulling and nutrients through water uptake, right? Mm-hmm. And so, they utilize that in the best manner when it's 80 degrees or less, right? And so we first thing in the morning, the sun hits the leaves, so we want a little bit of sunlight, on the leaves. We're gonna sap the east facing, always east facing, right? We're gonna pick an area and come back to that area, not the same tree, but the general area, right? Time and time again. For permanent planting, let's say, like, for example, a hedgerow, I had 100 trees of super high density olives, 100 trees to pull continuously from. Walnuts might be only 5 trees if they're very large trees, right? You might have an area of 5 trees that you go back to every time, right? But that's important to stay consistent there, to reduce variability. And then, when you're collecting them, you are collecting them in a plastic bag. And then that plastic bag, you want to seal that plastic bag, right? Ziploc bag, and keep it out of direct sunlight, and it's going to go immediately onto ice, right? Not directly, so we don't want to turn it into mush, but just paper towel and then directly over the ice. We want to keep these things cool in order to, because everything breaks down, right? As soon as we don't have life support, then you're going to see, them break down. So yeah, the important thing is, before, usually, it's like before 11 o'clock, before 10 o'clock even, right? We're going to get all sampling done. And when the temperatures are good, and that's the best time to do it. And then the 100 grams of each, Now, when you're in the field and you're trying to decide what's a new leaf and what's an old leaf, right? Because this is I always tell the interns that do this is so important. We are basing our fertilizer program off of what you sample. So don't mess it up, right? Nail it every time. We have to be absolutely as best as we can be every time we sap sample. So temperature, how we store it, sending it off overnight, everything's got to be as perfect as we can make it, right? And also, we want to maximize what this test will give us, right? And to do that, I picked this for a specific reason, and that is you can see where we had growth that stopped, right, at this, basically this node. Mm-hmm. And then we had new growth. This is last season, right? We're in the winter, so we don't have new growth. But this is at the end of the season, at the end of last season, this was our newest growth. Now, we obviously have an old leaf and we have a new leaf because this is new growth. This is what you want. You want to pick a branch that you know has had recent growth because we want to understand the relationship between the old leaf and the new leaf. And so I'm not going to pick a new leaf here and then randomly find the oldest leaf in the center of the orange tree that might be 3 years old, right? We want to pick from the same branch. We're going to pick an old leaf, and on that same branch has new growth. We're going to pick that new leaf because that's going to tell us what's happening on that, right? As far as mobility. And we're going to do that consistently with every sample that we take. So we have a general pool of mobility between a branch that has new growth and old growth, right? And so it's very important. Now, the other very important aspect is we have these newest leaves that are very small, right? So they're not a fully developed leaf. So we're going to skip those and we're going to go to something that's a little more fully developed, either one of these two, right? That's what we're going to utilize. Otherwise, we'll have an off reading on these that are still getting pumped full, a lot of things, right? But this will give us a reference into what's happening, right? So we're going to take, I would take both of these on this branch, and I would come back here and I would take both of these on this branch. I would take these two. Sometimes I'll take up to 3 if it's growing fast and I can tell that they're still new leaves. I'll do 1, 2, 3, right? And then I'll go on to the next tree in our designated area. So those are the important aspects. There is a time commitment, obviously, and there is the time crunch of getting them overnight. But when done right, just a very powerful test. And another aspect of this old leaf, if it was, for example, like this one doesn't look like a complete leaf at some point for some reason, right? Mm-hmm. And so we do want that complete, fully developed leaf, right? That's not yellow or that's not eaten out by a leaf miner, right? For citrus, right? So we're going to take fully developed that looks representative, right? Representation is very important. So if the whole tree is yellow, we're not going to go to the one branch that looks green. We want what's representative, yes. Right? If the whole orchard is struggling, then we want to get the most representative so we know what's going on. Absolutely. And I've had some interns have a tendency to find that perfect green leaf, and it's like, no, something's not right. We know there's issues out there. How are we getting such good results? And it's like, well, I found the green leaves, So anyway, all the little details, right? Well, let's first start with this. This test was done by New Age Laboratories out of Michigan. I've looked at a few different facilities. I chose New Age because I truly feel like they're third party. They don't, because there's a lot of testing facilities out there that also have recommendations with products. And I think that's a conflict of interest, right? I'm trying to be as objective as possible. So that's why I went with New Age. To give you an idea of turnaround, I'll send samples, leaf samples in on Monday, Tuesday, overnight. And then I'll get the results back Wednesday, Thursday, and Friday. So my whole goal as far as execution is take samples every Monday, Tuesday, sometimes Wednesday, get results back at the end of the week, make a decision, deploy hopefully by Monday, So that turnaround is awesome. Now, does that happen every time? No, but can it? Yes. You can absolutely, like, you know, that's the turnaround, which is really helpful, especially when you're doing trial work, right? And if you're trying to reduce risk. When we get these results back, they just come, you know, via PDF, whatever. Also raw data, so that you can start graphing your own results. But let's just look quickly at what we're seeing here. On the right, or on the right side, we see graphs, like a bar graph. And then on the left, we have some parameters, the units, the optimal levels, OLs, and the results, right? So we have the actual quantitative data here on the left, and then there's a visual to it, right? I often don't look too much into the visual because it's just a bar graph, and oftentimes it just can't quite represent what, you know, it's great, but always look at your actual levels, right? Now, this data that we have is based on the data that we have for walnuts in the state of California. That's where the data comes, right? And that's where the optimal levels come. Now, I take optimal levels as more of an average level because it's based off of what we have as far as baselines in the state. I don't spend a lot of time on OLs. Again, the power in SAP analysis lies with the ratio. Let the tree tell you between the old and new leaf, right? Or the annual crop. Look at that ratio. Let the tree tell you what's going on, right? Everybody and anybody has their own ideal of OLs, but it's a great reference point to see more or less where we're at, right? As far as parts per million. Let's just start with, you know, calcium as an immobile nutrient. It's a cation. And if I look at the new leaf on the graph is going to be lighter in color, obviously. That's kind of representative of what we see in the field, right? And the old leaf is the darker color. So when it comes to calcium, an immobile nutrient, right, then we actually want more in the new leaf than in the old leaf because it doesn't move. So if we have more in the new leaf than in the old leaf, we know that at least there's enough that the leftover went into the new leaf for growth, right? As it's pulling from the soil, right? So if we look at the new, in general, I'm still low, right? So I could work on parts per million, you know, or OLs, but I'm really looking at that ratio and really learning from it like, okay, it's utilizing what we have, but we could use a little bit more, but I'm not super concerned. We absolutely could utilize more though. The new is 180 parts per million and the old is 110, okay? We look at that ratio and it's like, okay, there is calcium in the system and there was priority in the new leaf to have calcium, so a lot went to that new leaf. Now, there's not a bank, so it can't store it and mobilize it. Now, let's go to the next line, which is potassium. Very telling here. Potassium, the new leaf, far exceeds, as a mobile nutrient, far exceeds parts per million than the new leaf. Than the old leaf, sorry. The new leaf is 3,310 parts per million over 1,270 parts per million. Not really a good place to be in. I obviously was very deficient in potassium at that moment in time. Now, again, I always say my farm's a bit of an experiment. I don't add a lot of anything and I'm just observing. Maybe that's an expensive experiment, but that's just what I do, right? How can I talk to a farmer unless I really understand the far extreme, right? Like, I'm the one that's made all the mistakes and I can learn from me, you know? But you can easily tell that at this moment in time, I'm not maximizing my production on crop or growth because I'm underutilizing potassium because it's not available in the system. There's such a need for potassium that has borrowed considerable amounts from the old leaf in order to give the new leaf what it needed at that moment in time. Okay, so those are two examples of an immobile and a mobile nutrient. And so then you start, you know, with mobile and immobile, let's just use potassium. We really do want about 20% more in the old leaf, right? If we have more than 20%, then it's like, you know what, we can back off on the fertilizer, right? Back off on potassium. But at this moment in time, I would say that I should have applied some sort of formulation of potassium, right? But that's where the cost savings happens, is when you see an abundance of one in the old leaf on a mobile nutrient. And so you could essentially back off. So that's kind of how you know, you begin to read the SAP analysis. There's mobile and immobile nutrients. We won't get into it now, but then there's also looking at the relationship between different nutrients, right? Antagonism, cations versus anions, the antagonism and the synergism of nutrients. And that topic of study is endless. Like, it really just goes on and on and on, and it's different for every crop.
With that respect, how often do you do your SAP analysis?
Okay, yeah, no, great question. All right, so with annuals or our row crops, it's going to be a little more frequent, right? We have a single growing season. We got to nail it in sometimes only 90 days, right? Or less, you know, with some of our leafy greens. And so that could be weekly or bi-weekly in order to really, you know, maximize that nutrient management in a short window, right? Permanent plantings, a little different. I typically do once a month, unless it's during something important. Like in the springtime, we have a lot going on, phenologically speaking. We have, you know, bloom, and we have post-bloom. We have nut or seed development. Nut development. These are permanent plantings, right? And then, you know, cell expansion. You know, all these things. So there's a lot happening. So once every 3 weeks, sometimes as frequent as once every 2 weeks on a permanent planting during that spring time when there's a lot happening. Or, you know, for certain fruits that really need a lot of fruit expansion, then it's going to be more frequent during that fruit expansion. And I will say, like, after a full season of at least doing once a month, then you start to
Oh, it looks like the video, the very end got cut off, but I think that is most of the content there, most of the video, and so I didn't see any questions in the chat, but I would like to see if anyone has questions at this time that we can discuss. If not, then I definitely have some questions, so I'll give people a minute. Gonna unmute yourself just for your question. Scott, it looks like you have a question.
Yeah, thanks. I actually had a good opportunity of meeting, oh gosh, I've already forgot, Clayton. And he's a really, really nice guy. I remember him showing me this, the test result that he had done on his own farm, getting to see here. And I remember being just as confused then as I am now. And I'm realizing it's not about confusion. Like, I know when I read a test result, it's that SAP analysis has a very, very different way of interpreting the test results than does traditional tissue sample results. And I was wondering if you have other resources for places where we could, you know, get a more in-depth, you know, we talk about the ratios, the cation and the, you know, the different exchanges, the mobile and the immobile nutrients, which most of us should know if we know our soil samples. But how to actually read that in a SAP analysis still seems somewhat mysterious to me. Really cool testing method though, and it was cool to see Clayton on film. So thanks for that.
Yeah. Yeah, thank you, Scott. It is, I felt like even the first season that I did it, we pulled about 400 SAP the first season that I got into it. And I felt like it took me that full season to just get the basics down as far as how to interpret SAP analysis test. So resources, if you're utilizing, let's say you're utilizing new age laboratories, take advantage of every class that they offer for the interpretation of that test. So that's really where my knowledge came from, was directly from Jenny over at New Age Laboratories. I went through the training with her and multiple trainings with her, and then the conversations. I oftentimes had to pay for those. Well worth my time, well worth my money, because it just I felt like every session I learned a little bit more and a little bit more. And so that was my biggest resource as far as how to interpret SAP analysis. And also, I love talking about SAP analysis, and I love helping people understand it. So save my contact information and just, give me a ring after you take a SAP. I feel like it took me a long time to understand. It's challenging, but once you kind of get it down, it really opens up a whole new world. Hopefully that answer helps, Scott.
Yeah, that was really good. Thank you.
Any other questions? I see that, one came in from the Q&A just now. So an in-field testing tool for SAP analysis would be amazing. Is that in the works, or is that a totally crazy notion? Clayton, do you know?
We've talked about this, and I know some of the tests that they are using, I think it's three different machines to actually do these testing methodologies. And I think they're like upwards of like $16,000 each. Now, what has happened over time? I mean, I have the biometer that I can go out and test my own soil now with biology, right? Which gives me more or less an idea of where we're at. So in time, I do see it happening. We just have to wait for the technology to get out there in such a smaller device in real time. But I'm not aware of anything right now. The closest thing that I utilize is just, okay, let me back up. I did try to do it on my own. There was these little tests, they're called, Varabi tests or something, but there's these little handheld tests that you can crush the leaf and pull sap out of, and then drop it on that Varabi test, and it'll give you real time. So what I learned from that was the first time I tried to do it in-house. But two things. One, I'm actually crushing that cell, right? I'm extracting sap by not withholding the integrity of the structure of that leaf. And so it's not going to give me the same reading as a true sap analysis that extracts sap without compromising the integrity of the structure. So that's one thing that you have to realize when you do it on your own, because there is those handheld Varabi tests that I was using. Second, I noticed on certain nutrients it was very consistent, very predictable, and others, like all over the place. We could take the same drop, same plant, and dropping it on that same meter and calibrating and it'll give me different readings. Like it was just, I'm pretty sure potassium was kind of all over the place. So it was really hard at this time. I think a lot of these tools are, they're still preliminary, and we're not able to extract the sap without compromising the integrity of the cell wall. But in time, I know it's going to happen in time. Hopefully that.
Yeah, great. Another question is, any suggestion about doing this for garden crops versus field crops?
Yeah, the only suggestion I have so I've done it on my homegrown tomatoes because I wanted to see homegrown compared to a lot of the conventional and even organic guys that I work with. And honestly, I saw similarities. I mean, there was in California, we just see we utilize a lot of calcium and potassium in tomatoes, which is different than the data that we have from the East. They just, based on soils, they utilize a different amount, parts per million wise. So back to the original question. So if you have issues with, let's say, tomatoes or peppers, and you want to understand, yeah, it's a bit expensive, but it'll definitely give you a view of what's going on in that plant. And I know for my tomatoes, I was actually doing much better than a lot of the commercial guys, but that's because I'm an organic gardener that's focusing on absolute soil health and my so I was really utilizing biology, so it looked pretty good and I never put anything on it compared to the conventional guys that we put a lot on, or even the organic guys put a lot on. But yeah, definitely worth doing in your garden if you want to understand where your soils might be a little low as far as availability and what things you might want to focus on. Here's something interesting, and I have a tendency to go down these holes, but you saw in the video my cattle, and it's an organic herd, and I feed them organic supplements, which are just nutrients, and like iron, zinc, manganese, I have 8 different elements. What I noticed the cows took the most of with those elements that I offer free, free feeding, were the exact nutrients that my tree was deficient in. So what I take away from that is there's still, even though I'm biologically farming out there, there's still room for me to get better at my biology. I know I can unlock more of the correct biology, and we have to look at our soils as being kind of compromised for a century, maybe at least many decades, if not century or more. And so to turn it around is hard, but I love testing so that we can see, okay, what do we need to focus on? And if you look at maybe even Dr. Ingham's work, if we're low in potassium and you want to increase your biology with potassium, or then when you're making a brew, make sure that you have a very strong potassium, element to that'll facilitate the potassium facilitators as far as microbial populations. So anyway, long answer, short question, as usual for me.
Any other questions? We probably have time for 1 to 2 really short ones.
Yeah, I'm probably good till, let's see, 9:30. So if we wanted a few more, that's fine. Unless you needed to quit the.
I think we have to hop off at.
Unfortunately, we only have 2 more minutes
Oh,
left.
okay.
I have to start the next one.
Oh, okay. Sorry. Oh, sorry. My bad.
Clayton, when I send out a follow-up email, I can share your email too with participants if you're okay with
absolutely.
it. Okay.
Absolutely.
I think one more question from Scott.
Yeah, thanks. I wanted to respond back to the biology thing, because I think that is the thing. I think that is the difference between synthetic and like all the other practices that we're working on, primarily regenerative. The materials in like all the minerals, like in general, they're already there. And so the way that I think that you just said this, that really I think changed it for me, is that we're looking at from the other direction. We're not looking about what we can put into the soil, but we're looking about how we can activate the biology to bring from the soil what's already present. And I guess the SAP analysis, that makes sense, that it's really more about testing the changes you made in the biology that affect the plant in real time. So anyway, that was my epiphany. Thank you for that.
Yeah.
Thank you, Scott. And I'll send resources in the video to everyone after this, and then share Clayton's email with people that have lingering questions. So thank you.
Thank you, Hannah. Thank you everyone for being here. And I hope to see you at another workshop throughout the days, as this conference is 5 days long. And thank you so much for being here to our panelists, and have a great rest of your day. Bye, everyone.
Thank you.